All right. As was mentioned, I'm John Hayes, K7VE. I live about 20 miles due north of Seattle in a little town called Edmonds. Actually, I live in the county next to Edmonds, so you take the turning, you get off, and you keep going. As Jim mentioned, I'm going to talk to you about some of the new computing opportunities we have and how you can apply them to D-Star. I'm going to show you a couple other items. I've got about 11 slides is all, but I'll talk a bit. So, one of my sorry. So one of my Raspberry Pis is going around the room. How many people here have tried to order a Raspberry Pi? How many people have a Raspberry Pi? So when it was first announced, there were two companies that were distributing them, and the hour after the announcement I ordered on both, and I was fortunate to get one from each after 2.5 months, 2 or 3 months. For those of you that aren't aware of the genealogy of the Raspberry Pi, the computer science department at Cambridge University made an interesting observation, and that is that the entering comp sci students had never hacked. Most homes have, very expensive computers, and parents don't like them going in and soldering wires to them, and writing their own operating systems or applications. So they thought that it'd be really good to get a computer into the hands of kids and students that was so cost effective that you don't care if they drop solder and short out the board, because you just go buy another one. And they came up with two designs, and they priced them in US dollars because as rough as our economy's been the last 4 years, our currency doesn't fluctuate as much as some others, and since international pricing isn't that way. So their first board, which I didn't have a lot of use for, but anyway, their first board was $25. And it had one USB port and 128 mega RAM, and it had all the GPIO ports, had no network connection. And so they came up with the second design, and they were both released at the same time, which is the one that you're looking at. And you'll note that it has an Ethernet port and a couple of USBs and an HDMI, and anyway, you have wires coming out from all 4 directions on them. And it has 256 mega RAM, and for a disk drive, you use an SD card. Pretty easy to get. And they're pretty inexpensive now. And but I will warn you, some SD cards are bad. You just have to deal with that. I'll have a URL here for you in a minute where to go to look for ones other people have had success with. Anyway, so it's a good one for experimenters and hobbyists and everything, and we'll talk a little bit more about it in a moment. But it's $35, not a bad price to pay. There's some other ones out there that are interesting. VIA makes a device called the APC, which has more memory and a little bit better processor on it. It's a slightly different form factor. It's based on the ITX architecture, but reduced. You can get it with Android on it, and then you can load Linux on it if you want to be more of a developer and so on. That one's $49. There's a group in Germany that's been building a lot of interesting hardware related to D-Star and other digital ham radio operations. they have a board out. You'll note kind of a pattern here. They all say ARM in front of them. That's an instruction set for the CPU. It is not Intel compatible, and as I understand it, the original goal was not to make it very power efficient, but it ended up being really power efficient as they started putting it. So it's in your Android tablets, in your iPhone, everywhere, and we get by with very low power and good cost. So their board has a lot of interesting things in it. It's got 6 serial ports, and it's got both A and B USB, and it's got Ethernet, it's got GPIO. I'm not sure what else it has. It's 159 euros, and I don't know what the exchange rate is today, but it's around $200. Then there's kind of an interesting set coming out of Hong Kong right now that have decent memory. They have a really good ARM processor in them. They're not really designed for people to go in and hack them. You can't. You got to have very good microscope to go wire some things in them. They're basically, they call them gum packs. They're about the size of a package of gum. They have typically a USB port on one end that you plug into something, and an Ethernet port maybe on the other end. And they run about $50 to $100 if you buy them direct from Hong Kong. So let's dig into the Raspberry Pi a little more. The board, as we said, was $35. The delivery's gotten a lot better, but if you're in the queue, you're waiting for yours. But if you go order one today from one of the alternate places that are starting to carry them, I've heard of people getting them in as little as 3 days. So shop around. Don't pay the premium on eBay anymore. A lot of people were buying them on eBay and selling them for 70, 80, 90, 100 bucks. You can get one, you may just have to look around a little bit. So you need a power supply and a cord. I typically use something that some of you might recognize. Anyone seen one of these before?
Oh, yeah.
Anyone seen one of those before?
Yeah.
You have a Kindle. That's the power cord for a Kindle. And it powers it just fine. The computer runs about 700 mils. You can find these cubes that are 500 mils. You don't want those. You can find them in amp. Those are okay. There are some that are 2 amps, which are even better. As far as the case goes, you see 2 models here. There's a couple of companies out there that are selling them. You know the little plastic box you put in your ceiling to put your electrical in? They're shaped like that, which I think is ugly. But their idea is you mount your board in it, and then all your cablings are inside of that circle instead of hanging out the side of the thing. You can wrap them out to one side, so I guess that appeals to another. The other big place to get boxes is no, it won't quite fit in an Altoids. And you got too many connectors going in different directions. I guess you could trim it off, but that kind of hurts the ground plane and so on. Is Legos. A lot of people are building cases out of Legos for these. They fit in a Lego framework very nicely. So there's a few operating system distributions available for it. From the Raspberry Pi site, you can get 2 versions of Debian, a version of Arch Linux. There's a couple other specialized ones out there. For the stuff I'm going to talk about today, you would want to use the Wheezy version, which is the second one down in the list. And it uses soft floating point. There is a Raspbian version which takes advantage of the floating point processor. If you write software with dynamically linked libraries that call floating point functions that are in the operating system, their soft floating point and hard floating point formats are different. So strange things happen, like if you're running DPRS reporting off of this thing, all of a sudden north of Seattle is somewhere off the east coast of Florida, and that gets a lot of water in your radios. One thing that I will advise, they're very weak in the USB area. You can only source about 100 mils between the two USB ports, even with a good power supply on it. So if you're hooking up any external devices, I recommend using a powered hub. It supports a lot of hardware. I've made all kinds of things work with it. But if you're looking for it to work when you buy it, check the list on the URL I have there. I found it to be quite good. I like people to learn how to use the command line. You can also export X windows or run VNC to get the graphical display. One of the things that they added recently, the images that they send out from the site here are typically just under 2 gigabytes. The sweet spot for pricing right now is in the 4 to 8 gigabyte range for SD cards. So people get that and they go, oh, I'm not using all of it. They go read a bunch of recipes to figure out how to extend it out to use the whole thing. They now have it as part of the startup script. You can say, go ahead and fill up my whole SD card, which is really nice because I typically buy 8 gigas. Did I get my card twice there? Well, that's cute. What can you run on it that's D-Star related? So you can make it a gateway. And I've run a gateway on this along with the repeater controller for 2 months at a time. They stay up just fine. They draw, like I say, 700 mils. If you're looking for a low-cost way to do a gateway without buying some big box or recycling an old box, they work just fine. So you attach to that some kind of controller that you need to use. So the software that I'm talking about here, IRCDB Gateway, which has been ported to it, it will talk to an ICOM IC R2D controller. It will do both DD and DV, so if you have a full stack and want to get rid of the big noisy hot computer, you can do it with something like this. But you won't be able to run G2 on it because it's only built for Intel processors, so you have to run a gateway like IRCDB Gateway. There's a sound card repeater, so you can attach a USB, something like the URI to it, or a USB sound card. I'll tell you, you want the cheapest sound card you can find, because you don't want any filters on it. GMSK doesn't want you modifying the signal, and they'll get wrapped up around there. There's something called the dummy repeater. You take Robin's dongle, you plug it in. It looks like a repeater to the rest of the network, but you can use it to carry on a QSO on voice using the dongle in a headset. DV repeater is a board that the Germans have made. Right now they're out of production. They're switching model numbers, but very good. I have a homebrew literal garage repeater at my home. I use that board on it. Its sensitivity is really good. Jim offers the GMSK repeater or GMSK node adapters which operate with the GMSK repeater. There's also a module to talk to the DVAP, so you can use the DVAP as a hotspot back into the network coming off of the gateway as one of its modules. So, Robin and Jonathan, who wrote this, have talked to get the handshake between the two a little bit better. Something called the split repeater I'll talk to in a moment. and a simultaneous cast feature, which is something that a few areas have been looking for. Reflectors, you know, you can run by StarNet on it as part of the gateway, and something coming called UDR repeater. So that's where that is. So I see that it duplicated some slides when I was editing. I apologize. So how many people here are familiar with the IRCDB network? Okay. How many of you have heard of the U.S. Trust Network? How many are you aware that if you have the right software installed, you can talk to both of them out of a repeater? You can. So here's the state as of this minute. Right now, there are 600 IRCDB-based systems online, 510 U.S. Trust-based systems. There's an overlap between those two in that 251 of those gateways are on both networks, physically on both networks. So that leaves 347 that can only talk to other IRCDB systems, and 257 that can only talk to U.S. Trust systems, or about 41%, that can't talk as widely. So to give you an idea, come on. There we go. So everything on the IRCDB network is reported in real time. So what you can see here on the service map is there's a much higher concentration of gateways on the European side of the pond as there is here. The green ones are online and active at the moment. The red ones are not reporting in. The yellow have some kind of problem on them. If we zoom in a little bit here to my neighborhood, since I know it better than the area around here, you'll see that there's a pretty good concentration here. There's the one in my garage, which is active today. And if we really zoom into it, you would see a second repeater there. I actually have a little desktop repeater as well. I mean literally desktop, but you can only talk to it from the other side of the desk. But it shows up on the network. And there's some really good tools out here for knowing what's going on. For example, you're probably, if you're on DStar, you've run across this page before.
Oh, yes.
Yeah. So IRCDB has a similar type page, but as I said, everything on IRCDB basically updates in real time. This one provides a live update. I'll refresh it once here because it may have lost its timer. But basically, you can sit with a repeater that has the IRCDB protocol available to it and key up your transmitter. You'll see the color of your line change while you're talking. When you release, you'll see it release, and then it'll give you a bit error report if the gateway repeater combination can compute it. Some can't. So it's a good way to go. You'll note here some have alt asterisks in them. There were like 2 guys in Germany that were concerned about anyone knowing when they were on the net. So they put in a feature that you have to opt in to get your call sign to show up. Your transmission will show up, but your call sign won't show up unless you do it. So all of that happening in real time. It does update everything. So I think it's pretty cool. So the other thing that this gateway does is it has a lot of capabilities in it. One is something called split repeater. You'll see it up at the top of that diagram there. a common practice in analog repeaters for a long time is to have voting receivers. And you take the signal strength and you pick the best one. Well, that doesn't really work as well on digital because the stronger repeater or stronger receiver may have more multipath and thus have a higher bit error rate, which means you're going to hear more problems in the signal. So what split repeater does is it compares the computed bit error rate of the two receivers coming in and picks the best bit error rate. So it may have a signal of like S0, but perfectly clear, and the one with S7 is all garbled. So we're trying to avoid that. So that can go into the gateway and out to the network, link to reflectors, do call sign routing, anything else that you want to do. You'll note here there are some bands represented that ICOM doesn't make radios for at the current time. Some of those have gotten filled in. You can now get a 10-meter D-Star radio if you want to sell one of your kids from ICOM, and they're going to have a more reasonably priced one soon. You can also do the same on 6 meters, which is kind of an interesting band for this mode. Both of those are bases, but still, well, they can go mobile, but you're not going to carry them around in your pocket. Of course, the antenna hanging above your head is kind of a problem anyway. So, but where we're going with this is an idea that I called simulcast repeater. Who here's heard of PavePause? One of the things that you can do is split repeater. That's one repeater. It can have up to 2 receivers and up to 2 transmitters. Simulcast, you'll be able to have N receivers and N transmitters. And all of the repeater drivers for this can talk to either full or half duplex or as a simplex operation. So what we think of as a hotspot, we can put out there and have it be part of a master repeater. It uses one frequency, which is kind of nice. Or you can put a full, repeater with duplexers and everything else on it. So what you end up with is, and they all have the same call sign. So, if you're on NW7DRA, which might be my simulcast repeater, every RF point that you access it, that would be RPT1, and RPT2 would be the gateway. So, circling back to PavePause for a minute, part of the problem is if you're on top of the mountain. And if you're building a full duplex repeater, and we'll use ICOM's pricing for things, you're looking at about a $6,000 investment to go on one band, right? So what you'd like to do is move it to the valley, put up more nodes that cover in some of those shadow areas and that kind of thing, and have them all act as one repeater. We also have some areas in the country where they have 10 or 15 repeaters hooked up 24/7 to the same reflector. Well, if they want to link to another reflector or to do some call sign routing or something like that, then there's some complexities that go into that. That the reason that they're 24/7 linked up is because they want an Uber repeater. They want something that covers a region. They have one like that in New England, and there's a fellow in Ohio that's looking to implement this as a statewide emergency repeater. Another thing you can do with it is using it as the basis for a radio, doing D-Star. Basically, you need some software. Here's an example. You need to add AMBI. Today, it's the DV dongle. My company's going to be offering something after the first of the year, not directly competitive with Robin's offering. We think there's a place for both, and then the Germans also offer one. I'm not going to jump out to all those sites right now because we're coming down on time. You add an adapter, whether it's one of Jim's boards or one of the German boards or a sound card or things that Robin might be coming up with to get it into the GMSK modulation. And then you just need a radio that has a 9600 baud packet port on the back of it. And this software will let you talk to people on the radio using your dongle, but locally. And there's just an illustration of how that might work. So a while ago, I had this crazy idea, and I did a presentation a couple years ago at a DCC conference, and I did my D-Star presentation. I said, you know, what would be really cool? You know, there is a whole different side to D-Star that most of you aren't that familiar with. It's called the digital data side of things. And the reason that you're probably not familiar with it is the connectors, coax, antenna are expensive and take a lot of work to put on right, and the radio costs a lot of money, being the ID1, which is a fine radio, but it does cost a lot of money. So I actually was in a meeting with ICOM Engineering at the time. I said, what I'd really like, I think you were in the meeting, Robin, is a radio that you plug an Ethernet cable into, an antenna into it, and a power cord, leave all the extra stuff off, and that's your DD radio, and do it for a more reasonable price. Well, this presentation I did a couple of years ago, I described that radio, and a guy came up to me afterwards and he says, I want to build that radio. And he lives up in the San Juan Islands of Washington, and he's a former Silicon Valley entrepreneur. And so we put our heads together because he'd been thinking about doing something similar for RMS gateways. And what we've come up with is a single box right here. This is a very early engineering prototype, so all the chips are not in the same place they are now. But it's a radio. It's designed from the ground up to be a digital radio. It's not plugging into something analog. And we're speccing it for up to 56 kilobits. We can actually go a little higher. We can get into a longer discussion afterwards if people are interested. But we're not talking like Wi-Fi speeds or anything, because that wipes out the band anyway. It's going to be using IQ modulation, which means we have a choice of modems. So that argument of C4FM versus GMSK and all of that is a non-issue. And actually the D-Star protocol allows you to use 4-level FSK, which C4FM is just a version of. So if you want to get out of that argument, you can. It's a 25-watt radio. How many people have a 25-watt radio with that size of a heat sink on it? And it's probably not red. If you're running data a lot, you want to run pretty close to 100% duty cycle. So we've done a lot of thermal studies and so on, and we're working to have that be the standard operating for it. And you attach antenna, power, and network. It's also got 4 USB ports. 1.2 gig? No. 70 centimeters. And it will not have 2 SMAs on it. That's for engineering work. It'll have an N connector. We want a real connector on it, so we're not putting a SO238 on it. But an SMA, while a better connector, really looks funny when you run 1 5/8 inch heliacs into it. So we're avoiding that. Then we said, okay, so we got this radio. In most cases, you have to have an external computer, and you talk through a protocol like USB that has its own problems and a bunch of other things to get to the radio, to the modulator and the radio. So we built the whole computer inside of it. And it's an ARM computer, decent complement of memory. Again, you use SD cards to hold your programs. You can upload it. This prototype has an OTG connector on it, but the final version will not. We're going to use that for that real estate for something else. the other thing we said was, okay, so we got all of this, and that all by itself makes a great gateway back into the E-Star network. And I've run the software for it for about 6 months. We've had some re-engineering work to do on RF. As Robin said, on 70 centimeters, he had to go, what was it, 9 prototypes? We're on Rev 2. We're hoping we don't have to go anymore. Well, yeah, any more than that. We did have to take an engineering hit, but we're building a much better radio, as Robin discovered when he redid his. You can do it. Plus, we're going up to 25 watts, so you don't want some of the issues that come out of that amplifier. Anyway, I'll pass this around. If people want to handle it. That is the actual form factor.
So is the intention of this device that this device by itself would gain access into the network?
Yes.
It would, okay.
Yeah, so you plug an Ethernet into one end, that's hooked to your ISP, and you hook an antenna in the other end, and the software runs inside the radio.
So what's the purpose of the radio end of it then?
To talk to radios out in the field. This basically replaces a hotspot in its current configuration.
Okay, got it, okay.
Except for we're running a full gateway stack, so you have all the protocols.
Got it.
We can run the 56K DD, which is half the rate of the ID1. Part of that's a limitation of the band, but you have better gain or lower losses, and it propagates further, and so your effective throughput may be higher.
And would your plan B is to take this software radio and make it all flavors, or to make it D-Star, make it DMR and P25, all into the same package?
We're engineering it so it can support multiple, both digital voice and digital data protocols. Like the switching time from receive to transmit will be 1.5 milliseconds or less. And if you've looked at TDMA, you need that, right? So we've been running RMS gateway on it. We've been running a bunch of other things. There is no head on it, you'll notice. You'll control it through a web interface or a custom application using underlying protocols, so you don't need a head, basically. And we'll probably be looking at things for, my button's going the wrong way. So we'll be looking at some things, similar to what Robin expressed, where today you can take the Raspberry Pi, you can put a Wi-Fi connector on it, you can run an application on an Android or an iPad or something like that and talk to it through the network. We'll have those kind of capabilities as well. I've run GPSD on it, run all kinds of things on it. Anyway, so I didn't put it on the slide, but I have a card that you can all pick up. What do you think something like that's worth?
$12, $13. $500.
I'd say $500.
Yeah. So for $395, this is your radio. We will have an Ambi chip plug-in. The Ambi chip will use the newer Ambi chip, so that if you wanted to do some of those other protocols, it can handle the encoding. We have talked to the Codec 2 people. There's a lot going on there. So we're almost at the end of our time. I just had one last point I wanted to bring up. Ham radios had a very large address space on the internet for 30 years, and it's languished out there. Ryan Cantor, who controls that address space, pulled together a small committee of us. We rewrote the terms of service. Traditionally, everything had to go through University of California, San Diego, and it was very narrow pipe. If you have a relationship with an ISP where they will BGP advertise your block of addresses on the internet, you'll now be able to do that. It'll have to be a minimum of 256 addresses, because otherwise the other ISPs get mad at us. There is an agreement that you have to do. You have to provide some documentation. It must only be used for ham radio. But what it'll allow us to do is have IP-enabled ham applications have an address space that we know. So that'll improve our confidence. So we'll wrap up here, and I'll be afterwards when people want to leave. I'll take your questions, but let me just set some cards out here real quick.